Ever wonder why a car will overheat? Radiator problem? Engine problem? Is coolant not enough? All these problems has been solved, but your car still overheats. Why? Well, the problem is the coolant. Nowadays, we have different color of coolants in the market, such as blue, red, and so on. Yet, none of that can solve your car problem. You all know that coolant helps to transfer the heat from the engine to the radiator. But can your coolants really transfer the heat away fast enough for a long way of driving? Now, let me introduce what nanofluid is first. For nanofluid, there is a lot of nanoparticles inside a base fluid such as water. How small is the virus look like? Or imagine the diameter of your hair, but smaller in 1000 times. And that's how little of a nanoparticle is. How does the nanoparticle move? Is it in a fixed direction? No. It's moved very randomly and freely. Thanks to Albert Einstein, we all know that this is called Brownian motion. Generally, larger particles occupy a larger space. Imagine a box can fill up to 6 sockers. Now, you change to fill the box with tennis balls. For sure, you can fill more than 6 tennis balls, right? Suppose I replace the particles in coolant with nanoparticles for the same volume of coolant. In that case, I can have more particles inside it. When all the nanoparticles move randomly and at high speed, heat can be brought away faster. Your car will not get any more overheating problems. Sounds logical, right? Nanofluid has proved to modify the thermal and hydrodynamic properties and subsequently to enhance the forced convection heat transfer. Since then, many researchers have started to investigate the heat transfer characteristic of nanofluids. However, only a few of the studies are focused on predicting the thermal properties of nanofluids. After that, a numerical simulator based on dissipative particles dynamic (DPD) for the prediction of the thermal properties of nanofluids has started to develop. As it is a developing simulator, the validation step is a must to prevent huge difference between the simulated result and the actual result from the experiment. And that's what I'm going to do. To validate the existing simulator, I propose comparing the past result from the research paper and the simulated result. Firstly, I will look for the particle's trajectory and the average velocity of any size of particles. Secondly, I will use software to analyze a time lapse for the Brownian motion of any kinds of fluid found in online resources such as YouTube. Plenty of nanofluid research have been done, but most of them only focus on the particular types of nanofluids. Therefore, it's a time to collect and arrange how many fluids and nanofluid types can be found in all research papers. These two approaches are to make sure that there is sufficient data to compare with a simulator. After that, this data can be a piece of rigorous evidence to validate the numerical simulator. Suppose nanofluids can be implemented into the coolants in the future. Not only your car can maintaining at optimum working temperature, but also it can help to reduce the size of the radiator. With a smaller radiator size, aerodynamic drag is possible to reduce and save fuel consumption. With nanofluid as coolant, a faster car with low fuel consumption, killing two birds with one stone. Besides the automotive field, nanofluids are also useful in many fields such as industrial, nuclear reactors, and many more. To fasten the nanofluids development, a validated simulator is vital. Compared to the trial and error, it takes a long time and a high cost to obtain nanofluids desired combination during the stage of development. In the future, if a validated simulator is provided, for sure, the developing time can be reduced as well. People in the world can enjoy the benefits of nanofluid soon. That's all from me. Thank you.